Good morning, everybody. So today we are going to discuss one of the most important topic of theory of failure, that is related to the subject strength of material, and it is one of the most important as well as interesting topic. So we will cover this topic. Now, first we should know what is failure, because there are two words: the theory of failure. So, what is failure? Failure. So, generally, what we are failure means that it may be complete separation of the body, or it may be the materially deformed, means plastically deformed. So that means when the body is under load, the material may fail, means it may separate or in number of pieces, or it may deform permanently. Then in engineering sense, actually, when the material is deformed permanently, then it is called the failure of the body. Now, the failure of what? So, second part is what is the what we are going to discuss here in this theory of failure. Actually, we are going to discuss the failure of the material. Material are of two kinds considered here. That is, one is the ductile material, another is the brittle material. So, when the ductile body or the brittle body fail, that is the main concern of this theory of failure. And third point, why there are various theories of failure. There are various theories of failure because load may be a unidirectional load, or load may be a combined load. That is, it may be bidirectional load or bidirectional with shear stresses, or it may be tridirectional load or tridirectional with shear stresses. So the combination of various loads acting on the body. So when exactly the body will fail, that is the main point of discussion of this theory of failure. Now, actually, we are finding the strength of the body in the laboratory by simple tension test. So, the material what we have discussed is the ductile material as well as brittle material. What is actually ductile material? The material which fails, which absorbs more amount of deformation before failure is called the ductile body. Or we can say the ductility is the main property of this kind of materials. Ductility is the property by virtue of which the body can be elongated without fracture. And the brittle material are the material when under load which will fail without much deformation. And mathematically, if we see the percentage of elongation in case of ductile body, that is more than 15%, and for brittle material it is less than 5%. That is percentage of elongation. Now, in simple tension test which is carried out in the laboratory, so if we see, so this kind of graph we will get for mild steel. So there are various points A, B, C, D, etc. We have got. The D is called the ultimate tensile stress, and point B, it is the upper yield point. Actual strength of the body is defined by D. Strength is defined by the term that is called stress term. So maximum stress which is applied over the body when the material fails is called the ultimate tensile strength. And B, the point is called upper yield point, where the body fails. Why? Because after crossing this point, there will be permanent set produced in the body. So that means when the load is removed, the body will not come back to its original position. Means there will be some strain present in the body. So that's why, as per engineering sense, the body has failed. Now, if we see in figure 2, if we see that is the stress strain diagram for brittle body. So you can see the yield point, and after that the ultimate tensile point, or sigma ut. So this point, the gap is very small. So that means we cannot predict where the body will fail. So here this point is considered as the ultimate point. Now, if the material is under load, say ductile body, then we will consider sigma y as the failure criteria, or for designing we are considering sigma y as the strength value. And for brittle body, we are taking sigma ut as the strength of the brittle body. And after that, we are calculating the allowable stresses. Allowable stresses is obtained by sigma y divided by factor of safety. Similarly, for brittle body, sigma ut by factor of safety. That is, for designing purposes, we are using this. Now, next, the types of loading. There are various types of loads acting over the body. So, if the load is applied over the body in one direction, that is called unidirectional loading. Figure 1 shows that is a compressive load. Body is under compressive load. So, the compression of the member will take place because of the load. Now, second kind of load which is shown here, that is also unidirectional load, that is tensile load. So, in this, the body will elongate under tensile load, and this is the shear load. The load is applied over the body tangentially, so this kind of load is called tensile load. So these three loads are unidirectional load, and it is very simple to find out the stress developed under these kind of loads. So it is very easy to predict which point to be used for designing the material. But when the body is under bidirectional load, that is the bidirectional load is applied only the tensile load in along x direction and y direction. So because of the load sigma x and sigma y, the stress developed along x as well as along y direction. And this figure shows the bidirectional load with shear stresses on their planes. So for this case also, so it is not so simple to find out the maximum stress which is developed because of the combined load. Now, the last case, if you see this is a three-dimensional loading system where sigma x, sigma y, and sigma z are load acting over the body, and because of as well as also shear stress is acting over the body. So, because of this combination of normal stresses as well as shear stresses acting over the body, what is the maximum principal stress developed? So that we have to calculate, so that we can find the failure point. Now, these three cases, that is a simple loading, and these two cases are combined loading. So, in combined loading cases, it is slightly tough to find out the maximum stresses which will cause failure. If we consider an example, suppose some person is taking only chapatis. So how many chapatis he can take? So he may take 3 to 4, or he may take 8 to 10, or he may take, if he is taking more, and 19 to 20. Okay. So this is the case of simple tension test. That means maximum more than 19 to 20 he cannot take, means he has reached his saturation point. So similar case. So if we carry on increasing the loads, the material will support that load. But if we carry on increasing that load, after a certain point, the metal will fail. That means that the limit is reached. But in case of this, take another example. Suppose the person is taking chapati along with other items. Other item means, say, he is taking rice, he is taking various sabji as well as mutton, chicken, or sweets, etc. So now, can we say how much chapati he can take? Definitely he can take less than 20 chapatis. So that means his capacity will be decided by combination of various items. So here also same thing, because the various kinds of loads acting over the body, and the saturation point means failure point to reach. So before this, that means the combination of load will decide the failure point. Okay. Now next we will see the principal stresses. When the load is other than the simple tension, compression or shear stresses, the combined load is acting. So that time we have to calculate the principal stresses. So to get the principal stresses, and now first we should know what is called principal plane. In a material body, when the body is loaded, there are planes where the shear stress is zero. That plane is called the principal planes, and principal stresses. The plane on which shear stress is zero is called principal plane. So shear stress is zero means only normal stress is left. The plane on which only normal stress is left is called the principal stresses. The normal stresses which acts on the principal plane, that is called the principal stresses. And the maximum principal stress or minimum principal, there will be, in case of two-dimensional body, there will be two such planes where the principal stresses will act. One is the major principal plane where maximum principal stress is acting, and another one is the minor principal plane where the minimum principal stress is acting, and shear stress on that two planes will be zero. Similarly, for a three-dimensional body, there will be three such planes where the shear stress will be zero. These are the principal stresses. Now, mathematically, for a two-dimensional body, if we calculate the principal stresses, it will come two principal stresses for a two-dimensional body, and sigma 1, 2 is given by sigma x plus sigma y by 2 plus minus half root over of sigma x minus sigma y whole square plus 4 tau square. So, these are the two principal stresses which act on the principal plane, where when you consider plus sign, that will be the major principal stress, and when you consider the minus sign, it will be the minor principal stress. Now, because of this, the tau max, there are some plane where the tau max, maximum shear stress will occur, and it is given by half sigma x minus sigma y whole square plus 4 tau square, where the body is under sigma x load along x direction, sigma y load along y direction, and tau is acting on the faces. Now we are coming to our main topic, that is the theory of failure. There are 5 theories of failure. One by one we will discuss the theory of failure. The first theory of failure is the maximum principal stress theory. These theories are most important for exam point of view as well as for your academic preparation also. So, maximum principal stress theory, or is also known as the Rankine theory. So, this theory, as it is developed by Rankine, and the name is given as Rankine theory. According to theory, the material subjected to complex system of loading, so complex state of stresses, means the body is under sigma x, sigma y, sigma z, along with the shear stresses acting over the body, and that is called a complex system of loading. If the body is under complex stress system, the material subjected to complex stresses at any point will fail if the maximum principal stress exceeds the limiting stress in the unidirectional tension. So, we have seen the simple tension test where only tensile load is acted. Sigma y is the point where the body will fail. So, when the material is subjected to complex stress system, at any point, the maximum principal stress we have to calculate. So, body is under sigma x, sigma y, sigma z load, as well as tau xy, tau yx, tau zx, tau zy, or tau yz, tau zy. So, these are all the stresses are acting, or it may be some stresses, means more than one stresses are acting over the body. So, when the body will fail, that we are going to calculate. So, first we have to calculate the principal stresses developed because of this complex system of loading. Say sigma 1, sigma 2 and sigma 3 are the three principal stresses developed in the body, and where we assume that sigma 1 is greater than sigma 2 is greater than sigma 3. So that means the maximum principal stress which is developed in the body is sigma 1, and sigma 3 is the minimum stresses developed in the body. So this may be positive, this may be negative. okay, or both, all may be negative or all may be positive. Now consider that both all are say sigma 1 is tensile as well as sigma 3 is negative, means compressive stress. Now the maximum principal stress sigma 1 as per the magnitude. So if it reaches the tensile strength value in simple tension test, it will fail. That means when sigma 1 is greater than or is equal to sigma y value, then the body will fail. And repeating case is sigma 1 is equal to sigma y. Similarly, if the body fails by compressive stress, that means sigma 1, that is sigma 3, sorry, this one is sigma 1, sigma 3, it is a negative one, so sigma 3 when equals to sigma c, then the body will fail by compressive stress. Okay, so in case of these are the case of ductile body, but in case of brittle body, the failure criteria is sigma u. What we have seen that ultimate or sigma ut, that is ultimate tensile stress. So when sigma 1 reaches sigma u or sigma 3 reaches sigma c, so then the body will fail by compression. This one is by compression and this one is by tension. So this is the case of principal stress theory, and this theory is applicable for the body. And the drawback of this theory is that it considers only one principal stress, that is the maximum principal stress. The maximum principal stress, that is sigma 1 reaches the strength value in tensile, then the body will fail. Or the maximum this compressive stress which reaches the minimum value, then the body will fail by compressive stress. So this is case of ductile body and this is the case of brittle body. Only the maximum one it considers. This is the drawback of this theory, and this gives the excellent result in case of brittle body, and also it is used only for brittle body. Now next is, according to this theory, failure occurs when the value of maximum principal stress is equal to that of yield point stress. Yield point stress is obtained in simple tension test. Simple tension test, what we have seen or we are doing in our laboratory. Now, condition for failure, maximum principal stress is greater than the failure stress, means sigma y value. And condition of safe design. So if you go for so this is the stress value at which the body will fail, means this is the principal stress by which the body will fail, and the design stress or allowable stress is obtained by dividing it by factor of safety. So this figure shows the loading condition in a two-dimensional space, that is sigma y and sigma x, as well as the shear stresses acting on the plane. And the principal stress what we have got in two-dimensional plane is sigma 1 and sigma 2. And graphically, only two-dimensional figure we can draw graphically. So graphically, if we can represent this the stress condition or failure point. So sigma 1, sigma 2, and this value is taken as sigma y, sigma c, sigma y, and sigma c, sigma c. So it is taken, and this type of rectangle we will get. So now you can say so this is the boundary along which if any point falls here, say sigma 1 value is say the sigma 1 value is this much and sigma 2 value is this much. So we'll get this point. So then the body is safe. So because of that complex stress system, if any point falling outside this boundary, that means sigma 1 value crossing that sigma 1 value, that okay, and sigma 2 value is within limit, then the body will fail. So that means this is the region along which along with this, within this, if anybody falls here or here, then the body is safe. But if any point falling outside this region, then the body is held. Now next, the maximum principal strain theory. So body is under complex system of loading, that is sigma x along x direction, sigma y along y direction, sigma z along z direction, along with the shear stresses acting on the body. So body is said to be a complex, under complex stress system. So because of that complex stress system acting on the body, we can get three principal stresses: sigma 1, sigma 2, sigma 3 are the three principal stresses we have got. Now let, like other slide what we have seen, that is sigma 1 greater than sigma 2 and greater than sigma 3. Sigma 1 is the maximum principal stress developed in the body, and because of sigma 1, the maximum principal strain also will develop in the body along the sigma 1 direction, and is given by sigma 1 by E minus nu by E sigma 2 plus sigma 3. So it is given here. Okay, sorry, that formula is not here. So this is case of two-dimensional case, sigma 1, sigma 2, and this is the sigma 1 by E minus nu by E sigma 2 plus sigma 3 is the stress developed, and that is maximum strain developed in the body. So that maximum strain will cause the failure. Now, in case of simple tension test, what is the maximum strain developed in the body? The sigma y by E, that is stress by Young modulus of elasticity, that will give the maximum strain developed in the body. So the maximum strain developed in a complex system of loading is equal to the maximum strain developed in the simple tension test at failure point. So this theory states that material will fail when the maximum principal strain, because of the complex system of loading, becomes equal to the yield strain in uniaxial tension for ductile material. So that means used for ductile material. The stresses for bidirectional stress system, it is given by sigma 1 by E minus nu by E sigma 2, and for tridimensional or three-dimensional stress system, there are three principal stresses: sigma 1 by E minus nu by E into sigma 2 plus sigma 3, and which will be equated to this or this. So for a three-dimensional system, this is the stress at which the body will fail, that is sigma 1 minus nu sigma 2 plus sigma 3 is equated to sigma y. Thereafter the allowable stress is obtained by dividing this value by factor of safety. Similarly, for two-dimensional cases, the sigma 1 minus nu sigma 2 will be equal to sigma y, and the allowable stress is obtained by dividing this by factor of safety. And this is the maximum principal strain theory, and graphically it can be represented by this figure. So that equation what we have got, if we plot in a two-dimensional space, we will get this figure. So this is the maximum principal strain theory applicable for ductile body. And next theory, that is the maximum shear stress theory, which is most widely used for ductile body because of its simplicity of formula. Now, this theory is also known as Coulomb or Guest theory. Under the effect of complex stresses, means when the body is under complex stresses, the failure will occur when the maximum shear stress developed because of complex system of loading is equal to maximum shear stress in uniaxial tension test, what we are doing in all laboratories. Okay, so let the body is under complex system of loading, that is sigma x, sigma y, sigma z along x, y, z direction, as well as the shear stresses are also acting over the body. Because of that, we will get maximum three principal stresses, that is sigma 1, sigma 2, and sigma 3. And we are assuming that sigma 1 greater than sigma 2 greater than sigma 3. Then the maximum shear stress, what we will get by calculation is the sigma 1 minus sigma 3 by 2. This is the maximum shear stress. So this all may be positive, all may be negative, or sigma 1, sigma 2 may be positive, sigma 3 may be negative, or sigma 1 may be positive and both sigma 2 and sigma 3 may be negative. So by that combination we will get tau max. Tau max is given by sigma 1 minus sigma 3 by 2, where sigma 1 is the maximum principal stress and sigma 3 is the minimum principal stress. In reaction tension, only sigma y load is acting over the body. So what is the maximum shear stress? That is sigma 1 by 2, because sigma 3 is 0. So if you put 0, sigma 1 by 2, sigma 1 by 2 is the tau max in reaction tension. So this is the maximum shear stress which is developed in complex system of loading, and this is the maximum shear stress developed in simple tensile test in the laboratory. So when this value exceeds or equal to this value, then the body will fail. So equating this and this, we get sigma 1 minus sigma 3 by 2 is equal to sigma y by 2, or sigma 1 minus sigma 3 is equal to sigma y. So the criteria of design is sigma y is given by sigma 1 minus sigma 3 is equal to sigma y. Thereafter, the allowed stress for designing the material is obtained by dividing this with factor of safety. Okay, and pictorially, if we are graphically, if we present this, so because of sometimes it will come sigma 1 minus sigma 3, sometimes come it is in two-dimensional space. So sigma 1 and sigma 2 will be there. So this side is tensile stress, this side is compressive stress, compressive stress. So the figure is obtained like this, means the graph is obtained like this. So only that equations we are plotting here, and we will get the graph. Okay, when sigma 1 and sigma 2 both positive, the failure point will fall on this region, and when sigma 1 is negative and sigma 2 is positive, the failure point. Okay, so these are the boundary within boundary, the body will not fail, or it is, you can say, it is safe zone. But outside the boundary, if any point is falling here, or even here, the body will fail. So that means if either sigma 1 or sigma 2 exceeds, that is called the failure of the body. And this is for this theory is for that is brittle body, ductile body, and is most widely used theory because of the simplicity of the equations for calculation, simple for calculation. Now next theory is the maximum strain energy theory. Now before going to that, we will know what is strain energy. The energy stored in a body when the body is under load, because when we are, say, we are applying tensile or compressive load. So when tensile load is applied, body will elongate and some energy will be absorbed by the body, because when we remove the load or release the load, the body will go back to its original position. So that means some energy is stored in the body, and that energy is called the strain energy. Now, according to this theory, failure of a material is caused when the strain energy per unit volume under a complex system of loading reaches the value of strain energy per unit volume at the elastic limit in a simple tension test. Okay, so in this case, it is strain energy is given by half into stress into strain per unit volume. So strain energy per unit volume is given by half into stress into strain. So it is discussed in the respective chapter. Now the principal stresses. Say body is under complex stress system. Sigma x, sigma y, sigma z, as well as tau are acting over the body. So maximum three principal stresses will develop in the body, that is sigma x, sigma 1 plus sigma 2 and sigma 3. Sigma 1, sigma 2 and sigma 3 are the three principal stresses developed in the body, and if we calculate the strain energy, because of that, half sigma 1 into epsilon 1 plus half sigma 2 into epsilon 2 plus half sigma 3 into epsilon 3, and if we put the epsilon 1, epsilon 2, epsilon 3 value, then it will be 1 by 2 e sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 nu into sigma 1 plus sigma 2 plus sigma 2 plus sigma 3 and plus sigma 3 plus sigma 1. This will be the energy absorbed by the body. That is called the total strain energy absorbed by the body when the body is under complex system of loading, where mu is the Poisson's ratio. Okay, so if we apply this theory for a simple tension test and calculate, it will be sigma y square by 2. It will be, because sigma 2, sigma 3, put sigma 2, sigma 3 0. So that is sigma 1 square by, and sigma 1 in place of sigma 1, that will be the failure point in simple tension test is sigma y square by 2. So this is case of tensile stress and this is the case of compressive stress. So sigma y square by 2e or sigma c square by 2e when the body is under compression. So this is the total energy developed in the body. So when the strain energy developed in the body because of complex system of loading equal to the strain energy developed in the body because of simple tension test is equal, then the body will fail. So that means this is equal to this one will give this, or if we take compressive, so this will give this one. In case of a two-dimensional body, put sigma 3 is equal to 0, then we will get sigma 1 square plus sigma 2 square minus 2 nu into only this one will be there. So sigma 3 is 0, so this will be 0 or this will be 0. So this will be sigma 1 square plus sigma 2 square plus 2 nu into sigma 1 into sigma 2 equal to sigma y square. So this is case of tensile load and this is case of this one will be equal to sigma c square. So this is case of compressive load, and this is the maximum strain energy theory for ductile body, and graphically it can be represented by these graphs because this formula, if you put the points, so it will give this kind of graph in a two-dimensional base. This theory gives results fairly close to the experimental results for ductile material for which the stress and elastic limit is the same for tension as well as compression. Okay, anyhow, next and the last theory of failure is the distortion energy theory or von Mises theory. What is von Mises theory? The distortion energy theory says or predicts that yielding occurs when the distortion strain energy per unit volume reaches or exceeds the distortion strain energy per unit volume for yielding in simple tension or compression test of the material. In this theory, it is assumed that total strain energy developed due to the complex system of loading. So what we have seen in the last theory, that is maximum strain energy theory. The body is loaded under various loads or combination of various loads, and the energy stored in the body is given by capital U. So now here the total strain energy which is developed is not responsible for destruction of the body. So this theory says that some energy is used, some strain energy is used for change in volume of the body, and the remaining is used for destruction of the body. In this theory, it is assumed that total strain energy developed due to the complex loading is not responsible. Total energy is not responsible for distortion. Some energy is used for volume change, and the remaining energy is used for destruction of the body. Say a body is under sigma 1, sigma 2 and sigma 3 principal stresses. So what we have calculated when the body is under complex stress system. So there are three principal stresses acting on three principal planes, right angle to each other. So that one, that is the triaxial stress system, and say sigma 1, sigma 1. Okay, so this is used for volume change and some is used for destruction of the body. So this is the destruction component and this is the hydrostatic component, sigma 1 x, sigma 1 y and sigma 1 z we have considered, and sigma 1 x, okay, sigma 1, sigma 2, sigma 3. So average stress is developed by this. Now what we have discussed, this is the total strain energy developed because of the complex system of load, that is given by capital E. Some energy used for volume change and that is given by UV, and the remaining energy used for destruction, that is UD. So UD is given by U minus UV. Hence total strain energy stored in the body we have seen in the last theory, that is U is equal to 1 by 2E sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 nu into sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1, and nu is the Poisson's ratio. Now energy required for volume change is calculated by this formula. So we have just calculated is equal to 3 into 1 minus, so calculation is not shown, 3 into 1 minus 2 nu into sigma v square by 2e sigma v, what we have got, sigma 1 plus sigma 2 plus sigma 3. So just we have put here, that is sigma 1 plus sigma 2 plus sigma 3 whole square. Okay, so we have got this value, that is the UV. Now we will put the value of UV here. So UD becomes U minus UV. So U is this one is the U value and this is the UV value. So if you put this and calculate, so we'll get UD, that is the energy required for destruction of the body, 1 plus nu by 6e sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. So that is the destruction energy what we have got. So if we put this calculation in simple tension test, only the stress which is used for destruction is sigma y. So if we put sigma 2, sigma 3 is equal to 0 in this equation and sigma 1 is equal to sigma y, we will get UD becomes 1 plus nu by 3e into sigma y square. Now when this destruction energy in a complex system of loading is equal to this, the body will fail. So equating this one and this one, so we'll get this. So 2 sigma y square equal to sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square, that is we have got. So from here we will get sigma y, and the allowable stress is obtained by dividing that equation into by factor of safety. So sigma allowable is equal to sigma y by factor of safety. So sigma y is obtained by last equation. Sigma y by factor of safety will give this. And for a two-dimensional body, put sigma 2, sigma 3, sigma 3 is equal to 0. So this will be this. Okay, sigma 2, sigma y by factor of safety. So it will come here. This equation will come. Or sigma 1 square minus sigma 1 sigma 2 plus sigma 2 square. And graphically, if you plot this equation, so it will come here by taking various points of sigma 1 sigma 2. So if you vary various points, it will give this curve. So any point which is falling inside this bounded region, then the body is safe. That means the region is safe. If any point falling outside the region, outside this bounded region, so then the body will fail. Now, if we graphically, if we show all the failures, so it shows like this. that is principal stress theory, maximum shear stress theory, maximum principal strain theory, total strain energy theory, shear strain energy theory, and okay, all this theory if we put on a single graph, so it will be seen like this. So I hope the theory of failure one point I will discuss. We have understood what is theory of failure. There are 5 theories of failure, and these theories of failure are used for this theory of failure. The theory of failure, what we have discussed is applicable for static loading. Only for static loading, no other type of loading. Okay, static loading means when the magnitude of load does not vary with time as well as its direction. So the magnitude and direction of load will not vary with time. That kind of load is called static loading. So either the load that is tensile load, compressive load, or bending load, shear load. So if this kind of loads are acting over the body, either single load or combined load, then theory of failure are used to determine the safe load or allowable load, which is used for design of component. This theory is here applicability of this theory. Mainly this theory is used for designing the machine components or machines or structures or any kind of shape, any kind of structure or any kind of machine or any machine component. So this theory of failure is used to find out the design stress so that the body will not fail under that design load. So this is the main, and this theory is used for the material. Mainly we are segregating the material as ductile material and brittle material, and on this theory is used. Okay, thank you.